In this clip, I am going to have a look at another type of argument locus problem. Consider the problem which is looking for the locus of a point that follows a path such that the argument of z minus z1 over z minus z2 is equal to a given angle, let's say pi on 3. Before we start, let's just break this situation down. Now, z minus z1 is a complex number or a vector, and z minus z2 is a complex number. So remembering that if I have one complex being divided by another, that's the same as the magnitude or the modulus of the numerator divided by that of the denominator, and then this angle of the numerator minus the angle of the denominator. Now, the R1 over R2 is our modulus of the situation we're looking at, and the theta 1 minus theta 2 is the argument. So essentially, what this is the same as argument of z minus z1 over z minus z2 is the same as the argument of the numerator. Here I had theta 1 take away the argument of the denominator, and we want that to be pi on 3. Okay, now let's look at our z, z1 and z2 on a complex plane. So let's plot 3 points. Let's say our z1 is here, our z2 is here, and our z is up here. I am going to join those points. Maybe we'll just write our z1, z2, and z. Okay, let's join them together. Okay, so now I have joined my 3 complex numbers on our argand diagram. Let's look at arg of z minus z1. So the vector z minus z1 starts at z1 and finishes at z. So its argument is the angle it makes with the horizontal real axis. Let's call this theta 1 as we did earlier. And the vector of z minus z2 is this vector up here, and similarly we'll draw a horizontal line to indicate where that argand is. That would be this angle here, and we want the argand of z minus z1 take away the argand of z minus z2 to be pi on 3. Now I'm going to construct a line, horizontal line through z. Let's break this up into its 3 angles. This angle is co-interior, and I have a set of parallel lines with theta 1. So that would be 180 minus theta 1. This angle is alternate to theta 2, so it will be theta 2. And let's call the angle at the vertex of the triangle alpha. So alpha plus theta 2 plus 180 minus theta 1 equals 180. Let's take away 180 from both sides, and I have alpha plus theta 2 minus theta 1 equaling 0. But our condition is that theta 1 is equal to pi on 3 plus theta 2. Combining these two equations, where here I have theta 1 equaling alpha plus theta 2, this means alpha must be pi on 3. No matter what our theta 1 and theta 2 are, based on the conditions set by the question, alpha must be pi on 3. So we need to refer to another part of our mathematical knowledge. Here I have 2 points on my diagram. They are joined by a line, and I am subtending an angle from this line in such a way that the angle is always going to be pi on 3. Now we've come across this before in circle geometry. The angle subtended by a chord on the circumference of the circle in the same segment are equal. Therefore, the locus of a point that satisfies arc z minus z1 over z minus z2 equals pi on 3 is the arc subtending the chord z1, z2.